right, math book's out, open to page 382. Great job on quizzes yesterday. Very pleased with how we did with the permutations and factorials and things like that. I want to move on to a new topic that is not a new topic at all. In fact, as we look at the problems, you're going to feel like we've been doing this. Yeah, we have. We're going to call it by a little bit different name, but it's exactly what we've been doing. I want you to look over at the side board there, where we've got that the top of a large Whitman sampler box of 74 chocolates. And of course, we said that there are in the entire package only 2 little milk chocolate messenger boys. So out of 74, that's a 1 to 37 chance that if you dumped all the chocolates out, reached in and just picked one at random, it would be a milk chocolate messenger boy. But I want you to look at the second one right next to that. The odds of pulling a coconut or a toffee. Well, in the entire box, there are 8 coconut chocolates, coconut candies. How many like coconut? How many do not like coconut? It's one of those polarizing things. You either love it or you hate it. I love it. But some people hate it. Well, the odds of coconut, well, that's 8 to 74, right? What about toffee? Well, that's 4 to 74. So what we would have done before is we would have said, well, how many coconut and toffee are there? There's 12 total, and we would have said 12 to 74. Because what you could do is say 8 out of 74, 8 to 74 is the odds of coconut, plus 4 to 74 is the odds of toffee. The two are not the same thing. If it's a toffee, it is not coconut. If it's coconut, it is not toffee. So therefore, 12 to 74 is 6 to 37 odds. You would pick one of those if the box had been dumped out. Does that make sense? We've already been doing that. But we're going to put it this way. The probability of something happening or the probability of some other event happening is equal to the probabilities added together. The probability of this happening or something else happening is simply equal to the 2 probabilities added together. And again, technically, we've kind of been doing that. There is one little caveat that's mentioned here. The events themselves, or the items here, must be mutually exclusive. And you see that term at the bottom of page 382. Mutually exclusive. That is, a coconut is not a toffee, right? Now, if I had said the odds of getting a coconut or a chocolate that is filled with something, well, a coconut is a chocolate that is filled with something. There's overlap there, right? They're not mutually exclusive. But that which is coconut is not toffee. Look at the events here. This person, George, has a die, which apparently has numbers instead of little speckled dots on it. And if he rolls a 1, he's safe. If he rolls bigger than a 4, meaning a 5 or 6, he's safe. What are the odds he rolls a 1 or something bigger than a 4? Well, what we would have done before, right, classes, we would have said, well, a 1 and a 5 and a 6, that's 3 out of 6. That's a 1 to 2 chance that he's safe, right? Well, technically, what we could have done is said, well, the probability of a 1 is 1 to 6. The probability of something bigger than 4 is 2 to 6. And if we add them together, now we get 3 to 6, which is 1 to 2. It's the same thing we've been doing. But here's the key to recognize is I want you to lock in on the word or. That's the key. The word or. Simply add the probabilities together. And that's what we've seen so far has always been the word or. They've never given us the word and. It's always been the word or. And for this lesson, we're going to continue working with or. This happening or this happening, you simply add the probabilities together. Look at the example problem 8.4 on page 383. Go ahead and read the example problem that is in bold there at the top of the page. Lana?
Mr. Todd's 8th grade class was asked which subject they liked best. Of the 36 students, 18 preferred math, 4 preferred history, 8 preferred science, and 6 preferred English. Express each of the following probabilities as a fraction, a decimal, to the nearest hundredth, and a whole percent.
All right. Again, we're ratio people here, so the decimals and the percents and all that. If we had calculators, I guess we would do that, but I don't feel like wasting the time. It'd be so easy to plug into a calculator. Y'all know how to divide, so we're not going to waste time practicing. I do feel like history doesn't get enough love here. I think history is pretty cool. I'm surprised there are more English people than history people. That kind of surprises me. Math, of course, being the #1 class, it makes total sense. But anyway, so part A says, what is the probability of randomly selecting a student whose favorite subject was either math or English? Now, what we would have done before class would have been we looked at how many math, how many English, so how many math or English? 24. And we would have put 24 over 36, and we would not have been wrong. It's perfectly fine to do this. But you also understand, you could have said, well, the probability of preferring math is a probability of 16 to 36, right? The probability of preferring, bless you, English is a probability, excuse me, that's 18, not 16, I can't read. 18 to 36. The probability of preferring English is 6 to 36. And then we could add to get 24 to 36. When you add doesn't really matter as long as you end up with this answer. Does that make sense? Except for where we're going to go in our next lesson. But for now, you're just adding them together. And of course, we would want to reduce, divide both by 12 to get 2 to 3, right? It's a probability of 2 to 3, or 66.6 repeating percent, 66 2/3%, if you wanted to do percent, right? 66% chance that one of the students you pick would prefer math or English as their favorite subject. But do you see how we're doing what we've already done, right? A jar of 30 coins. There's so many quarters, nickels, dimes, and pennies. Yeah. And what's the probability you pull a penny or a nickel? You just add the two together. And so we've been doing this whole OR thing before. This is not a new lesson whatsoever. There's, however, another way in which we could approach things. How about this? What's the probability of randomly selecting a student whose favorite subject is either science, history, or English? Well, notice what they did there. They said, well, science is 8 to 36, history is 4 to 36, English is 6 to 36. Add them all together, you get 18 to 36, or 1 to 2, or 50% probability. But you know what they could have done? They basically asked for everything except math. They could have just said, what's the probability of the complement of math, right? Because they asked everything but math. Well, math, remember, is 18 to 36, or 1 to 2. So what's the probability that it's not math? 1 minus 1 to 2, which is 1 to 2, which is the probability of science, history, English all run together. So sometimes you can use this to calculate, like if there's several ORs together, you may simply be finding a complement of some other event. Look at the next example here. Vacation transportation. How many people, when they take vacation, travel by car, plane, RV, train, or something else? They have them in percents this time, and that's perfectly fine. We'll roll with that. 59% take vacation by car. It's cheaper, except you have to pay for hotel fares if you take a really long trip. But anyway, plane, 33%. RV, only those who are rich enough to afford an RV, which is why it's only 5%. Train, I actually think it'd be really cool to take a vacation by train, but it's also ridiculously expensive, but I think it'd be really cool. But 2%, and then other, boat, yacht, cruise maybe, I suppose, 1% of vacationers. Okay, so supposing the question were asked, what is the probability a person will travel by car or plane? Well, when you see OR class, you have to do what with the probabilities? Add them. So car or plane, you add car, you add plane, and you get 92%. Got it? Not blowing anyone's brain here, good. So if we wanted the complement of planes, see, for instance, the probability that you don't go in an airplane because, you're scared to fly, or you just don't have the money, okay? Then you would add up all the other ones, right? Car, RV, train, other, add them all together. Notice 67% would be all the things but plane. Or you could find the complement of plane by saying, well, plane is 33. What's the complement of 33? 67. Make sense? So again, really nothing new here. It calls itself by a new name, perhaps, of mutually exclusive events. But really, truly, you're just adding up those probabilities like we've been doing. Seem easy enough? I point this out partly because it was mentioned yesterday. Someone thought we were going into this lesson and commented, that looks hard. And I got a corroboration from a second party involved. It does look hard, but I'm sure it'll be easy after it's explained. Do we agree? Pretty easy now that it's been explained? Yeah. So anyway, turn the page. Turn the page. Now, one thing I do need to help you understand is mutually exclusive. It is important because our next lesson, we're going to get into not mutually exclusive. And there's one extra step that's going to come in. It's not going to be hard, but there's one extra step. So let's take a look at number 1 together here. If you rolled a single die, okay, and we want to know what's the probability of rolling a 6 or an even number. Are those mutually exclusive? Is a 6 separate from an even number? No, a 6 is an even number. They are not mutually exclusive. So if we were trying to find that probability, we could not simply add. Does that make sense? Because the 1 is included in the other. 6s are included with even numbers already. How about the next one? Rolling a 2 or an odd number?
Yes.
Yes, those are mutually exclusive. So we would take odd number, which would be 3 to 6, 2, which would be 1 to 6, and add to get 4 to 6, or 2 to 3. Drawing a red marble from a bag or drawing a green marble.
Yes.
Yeah, absolutely. The two are mutually exclusive. What is red is not green unless you're colorblind. Technically then it still isn't, it's just you don't perceive the difference. No offense to anyone who's colorblind who may be watching on YouTube. I do not discriminate based on vision. All right, number 4, spinning a 1 on a spinner or flipping a coin and getting a heads.
No.
They're not mutually exclusive?
Well, right.
Is one included with the other? No, they're totally separate. They're mutually exclusive, right? So, yeah, 1 on a spinner, flipping a coin, and getting a heads, those are totally separate from each other. What would make them not mutually exclusive, again, is if there was some overlap. So, for instance, if we said the probability of spinning a 12, maybe it's a big spinner, spinning a 12 or spinning a multiple of 3. 12 is a multiple, that's not mutually exclusive, okay? So, unless it's something like that. Or, getting, what's your favorite color, Lana?
Teal.
You had to get complicated and go specifically teal. You couldn't say, what's your favorite color? Red. Thank you, sir. All right. So if we had, let's try to pick his favorite color. What is the probability of picking red or picking one of the colors of the rainbow? Well, red is a color of the rainbow. Now, Lana and her teal. Okay, that would be mutual, because teal is not considered one of the colors of the rainbow, though it might be in the spectrum somewhere. But anyway, yeah. So let's take a look here. So do we understand mutually exclusive? Okay, if the 1 is included in the other somehow, then it's not mutually exclusive, so this method fails. But, I mean, yeah, getting a 1 on a spinner, flipping a... So for instance, let's look at number 4. Lana, let me come back to you. How many numbers are on the spinner? You make it up.
15.
15, okay. So there's 15 different numbers on the spinner. What's the probability of a 1 now, class? 1 to 15. What's the probability of getting a heads on a coin, class? 1 to 2. So what's the probability of either, there's a coin flip and a spin. Go. All right, what's the probability of getting either a 1 or, was it a heads? A heads.
2 to 30.
Well, we have to add these together now
2 to 70.
to get 2 to 30 and 15 to 30, and that would give us 17 to 30, right? You just have to add them together. You have to get a common denominator, which is a bit of a bummer. But yeah, just add them together. There's a 17 to 30 chance that between the two of those, spin and flip, that you either get heads or you happen to get a 1. Does that make sense? All right, so number 5 through number 8, we're not going to take the time to write these because I'm lazy, but if we were to find the probability of getting either red or orange, maybe it's Skittles out of a bag, how in probability notation could I write probability of red or orange? Well, when we see or, class, we remember we add. So Joshua,
P red plus P orange.
P red plus P orange. So number 6, the probability of, for instance, seeing an owl or a deer when you're out hunting.
P owl plus P.
P owl plus P deer. The probability of choosing a taco or a burrito when you go to, I started to say Taco Bell. I do not endorse Taco Bell, but, because they don't sponsor my YouTube videos. But if they did, I would endorse them. Otherwise, I might endorse Del Taco. But anyway, Lana, what's the probability of picking a taco or a burrito?
P taco plus P burrito.
And let's face it, when you've got other things like gorditas and chalupas and the crunch wraps and all those other things, most people ain't going there just for a taco or a burrito. Though Del Taco is mostly tacos and burritos. Anyway, number 8, the probability that someone is either tall or short.
P tall plus P short.
Which isn't 100%, is it? Because there's also people in the middle. All us average folks. All right, any questions on probability notation? All right, dropping down to number 9. All right, a jar of marbles contains 3 yellow, 5 green, 2 purple marbles. 1 marble is randomly selected from the jar. What is the probability of drawing a purple or a green? These are Mardi Gras colors, I'm not sure why. But what is the probability of drawing purple or green? Well, what's the probability of purple, class?
2 to 10.
2 to 10. You had to count the total number first. What's the probability of green?
5.
5 to 10. So what's the probability of purple or green?
7.
7 to 10.
7 to 10. Y'all got this? All right, do parts B and C. So what's the probability of yellow or purple? Josh?
5 to 10.
Which we would reduce.
Oh, 1 to 2.
1 to 2. What's the probability of yellow, green, or purple? Scott?
1.
1. 100%. 10 to 10. All right, questions on that? Number 10. We have a spinner. Now, if they said, what's the probability of a 2 or blue? Look at the spinner. That's not mutually exclusive. Agreed? Okay. They don't ask any that are not mutually exclusive, though, you'll notice. So, do number 10, A, B, and C. We've rigged them to make sure they are mutually exclusive for you. Thank you so much. Letter A, what's the probability of red or blue? Lana?
2 to 3.
2 to 3. 2 to 6 plus 2 to 6 is 4 to 6, which reduces to 2 to 3. What about a 2 or a 5, Scott?
1 to 3.
Good. 1 out of 6 is a 2, 1 out of 6 is a 5, adding it 2 out of 6 or 1 out of 3. What's the probability of red or odd? Joshua? What's the probability of red, first of all?
1 to 3.
Well, just without reducing, 2 out of 6, right? Probability of red is 2 out of 6, because 2 spaces of the 6 are red. What's the probability of an odd number?
3 to 6.
3 to 6. So what's the probability of either spinning a red or an odd?
5 to 12.
Whoa, careful.
Wait.
Remember, when you add
Oh,
fractions, you don't add the denominators. 5 to 6. 5 to 6 chance you either get a red or an odd. Questions on that one? Does it make sense now? All right, do we get others of it get all 3 correct? All right, any questions there? Let's go to number 11. Student will give a report, not a random report. Oh, there's the word random. I wondered where I got that from. That would have been really random. A student will give a report on one of 4 randomly assigned animals: bear, snake, buffalo, or turtle. That does sound rather random. What is the probability of being assigned the bear or the snake or a mammal? Ooh, a little biology review here. And a reptile or the bear or the buffalo. So what do we remember from life science? That's the question. Got to tell Miss Morris there. She helped you out with math class today. Unless, of course, you already knew all of this way before you got to Miss Morse's life science class, in which case, yeah, you probably should have learned most of this in like elementary sometime. Hi, how are you?
Oh.
Sorry. Do you have any history homework? All right. First of all, we need to find the probability of a bear, class.
1 to 2.
Probability of the bear.
Oh, bear.
1 to 4.
1 to 4. Snake.
1 to 4.
So the probability of either one of them is
2 to 4.
2 to 4, which reduces to
1.
1 to 2. Because you add the 1 to 4 plus the 1 to 4 to get 2 to 4, and then reduce it down to 1 to 2. What's the probability of the snake or a mammal? Okay, what's the probability of snake? 1 to 4. What's the probability of mammal?
2 to
2 to 4. So what's the probability of a snake or a mammal?
3 to 4.
3 to 4. What if it had said a bear or a mammal? That would not be mutually exclusive, would it? Okay, so then the system falls apart a little bit. What about letter C? A reptile or the bear or the buffalo? Well, what's the probability of a reptile?
1 to 4.
1 to 4.
2 to 4. A turtle and a snake are both reptiles. So 2 to 4. What about the bear? 1 to 4. What about the buffalo? 1 to 4. So what's the probability of reptile or bear or buffalo?
4 to 4.
4 to 4, which is 1. Guaranteed you're going to get one of those. All right? So it's like one of those, if you're like, I really hope I get a reptile or the bear or the buffalo. You're guaranteed to be happy. You might be a little spacey, but you're guaranteed to be happy, okay? So, take the good with the bad. All right, number 12. Each of the 5 letters in the word apple is written on a separate piece of paper and placed into a hat. One letter is randomly drawn from the hat. What is the probability of drawing at your seats? Answer part A, part B, and part C. All right, what's the probability of an A or an L? Scott?
2 to 5.
2 to 5. And again, you could do this 2 ways. You could say A is 1 to 5, L is 1 to 5, add them together, get 2 to 5. Or you could say, well, there's 1 A and there's 1 L, so that's 2 things out of 5. Either way would work. How about an E or a P, Lana?
3 to 5.
3 to 5. After all, there's 2 P's, 1 E, that's 3 things out of 5. Or E is 1 to 5, P is 2 to 5, that adds up to 3 to 5. What about a P or a vowel? Joshua?
4 to 5.
4 to 5. 2 P's, 2 vowels, that's 4 things out of 5. Or probability of P is 2 to 5, probability of vowel is 2 to 5. So a P or a vowel is 4 to 5 when you add them together. Notice either way works. Right? It's basically the same thing anyway. All right, number 13. Read it. Answer the question. First of all, you need to make sure you get your sample space correct. How many total fruits, class?
12.
12. All right, so orange or apple, Joshua?
6 to 12, we should do 6 to 1 half.
Perfect. 1 to 2. 6 to 12 or 1 to 2, because there are 6 apples and oranges total. Peach or banana, Lana?
5 to 12.
Good. 5 to 12. 3 peaches, 2 bananas makes 5. And then fruit that is not papaya. Easiest way to do this, instead of adding them all up, what's the probability of papaya?
1 to 12.
So the complement would be 11 to 12, right? And either way, you could have added the others together. Well, there's 11 other things out of 12. But questions on number 13?
Wait,
Did you get them all correct?
1 to 12.
No, 11 to 12. Not papaya is 11 to 12 because papaya is 1 to 12 and that's complements, right?
I subtracted
From
1 minus 11 to 12 after.
Oh, okay, no, papaya is the 1 to 12. So probability of papaya is 1 to 12. So probability of not papaya is 11 to 12. All right, number 14. The names of each month of the year written on separate pieces of paper placed into a hat, one paper randomly drawn. The joke I keeps running through my mind on every one of these is, you pull out of the hat, you end up pulling the tag out instead of one of the papers, like put all the names. Okay, what names are we going to give our baby? Let's let the family vote. So all the family puts the names in the hat, pull it out, size 14. It's a rough name. Every time it's the name of the hat, I keep myself like, nah, it's a dumb joke. I'm not going to say dumb joke. Like, what? I'm just going to say it so we can all get it over with. All right, number 14. All right, what's the probability of April, June, or March being a selected month, Scott?
1 to 4.
Good, 3 to 12, that's 3 months out of 12, so 1 to 4. What about the probability of a month ending in R or Y? What do you have, Lana?
2 to 3.
Good, 2 to 3. I believe there are 4 that end in R, right? September, October, November, December, the only 4 ending in R, and then your Ys would be July, May, February, and January. So there's your 8 out of 12. And then a month that either ends in L or doesn't have 30 days. And this is the one that's fun, right? So the saying, 30 days hath September, April, June, and November. All the rest have 31. Say February, which has 28 till leap year gives it 29. So there are 4 that do have 30. So what's the probability it doesn't have 30? 8 to 12. So not 30 is 8 to 12. And then we also have to find the probability of ending in L. When is it L? April. April ends in L. Okay, so it's like probability of L, okay, would be 1 to 12. So the probability of ending in L or not 30, 9 to 12, which reduces to 3 to 4. That one makes you think, right? Almost makes you write out all your months. You're like, I hate this, but I don't know another way to do it. Questions on this? Yeah, and then you got the little knuckle method, right? January, February, March, April, May, June, July, August, September, October, November, December. But anyway, if it's on the knuckle, it's 31. If it's in the middle, it's less. Yeah. Anyway, I didn't learn that one. I learned a little saying that my mom said over and over again until we had it memorized, which is what I said a minute ago. If you didn't catch it, go back and watch the YouTube video. All right, get my views up. All right, while you're at, sponsor my page. I laugh for money, but not so much that it's going to make me do evil, I think. All right, I want you to do numbers 15 through 18 now. They've given you, instead of numbers here, they've given you percentage probabilities, but things work the exact same way. So, at your seats, do 15 through 18, dealing with popular breakfast beverages. How many of you like milk at breakfast? Hey, orange juice? Juice of any kind?
Well, I like olive.
You're like, I like all the
Except for
juices.
soda, like
Yeah, I don't do soda at breakfast. I don't do coffee either. I'm weird like that.
Orange juice is sour.
Yeah, it can be. It started upsetting my stomach, so I just stopped drinking it. But I can drink all the other juices. So,
Yeah.
but just the acidity in the orange juice. But I used to drink orange juice every morning. Anyway, so 15 through 18. So Lana, don't think orange when you see juice. Think something else. Drink water with everything.
Water
And
at
juice.
Water at
And
breakfast?
Yeah, I've got a glass. I got juice and I've got water.
No.
What?
I'm a heavy drinker.
Water does not belong with breakfast.
Oh, sure it does. Water belongs with everything all day long. And even though Walmart will not endorse my YouTube channel, great value purified drinking water. Where else can you get 40 bottles for $3?
Who drinks soda at breakfast?
I don't know, unhealthy people? Glenn drinks soda at breakfast? No. Question. You can get what at the dollar store?
Wait,
What?
Yeah, how many? One bottle, $1? No, thank you. 40 bottles, $3. It's less than 10 cents a bottle. You can't beat it. It's the way to go. Unless you have one bottle, you just keep refilling it. But I'm lazy and don't want to go to the water fountain. So I'm destroying our planet one plastic bottle at a time.
Are you putting it as
Wait.
a reduced fraction?
No. You're just using the percentages they give you. They're giving you percents. So you do percents. Yeah, well, I don't have time to take it recycled, so I throw it in the trash can and it goes in the trash and it's terrible. It goes in the landfill, it's a
I don't know
waste.
how many people there.
It doesn't matter. Okay, so in working with percents are already fractions, right? A percent is just another way to write it. So when it says, what's the probability of water? It's 10.3%.
Oh,
It's right there.
This,
Right?
yeah.
Right. So what's the probability of juice or coffee? Well, juice is 39.7%, coffee is 45.8%, and when we see or, we add to get 85.5%. They just add them together. Does that make sense now? All right. Coffee or soda?
Wait, 88.5%?
85.5 when you add the juice and the coffee together, right?
85?
85. 8 plus 7 is 15, carry the 1. 1 plus 5 plus 9 is 10, carry the 1. 1 plus 4 plus 3 is 8. What about coffee or soda? 50% exactly. What about something other than soda? What's the quick way to do this?
Just add.
No, don't add them all.
Oh, the
1
complement?
minus, complement. You do 100 minus 4.2 to get
95.8.
95.8%. All right, so now that we kind of figured that out, right?
What was the answer for the last one?
95.
Do 100% minus 4.2%. You'll get 95.8%. All right, 19 through 22 now. 19 through 22, now that you've figured that out. So yeah, when you're dealing with percents, they should all add up to 100%, right? So you're not really comparing to a total. The total is 100%, so you just keep the percents as are. All right, let's see what we got here. Let's see, a bowling team kept records for their team competitions. The chart below shows the probabilities for each category. They won 58% of their matches. What do you call a bowling competition? It's just a bowling game? A bowling contest? I don't know. Anyway, so they win 58% of the time. They lose 20% of the time. They tie 17% of the time. Now, I would argue a forfeit is the same thing as a loss, but they've got it in a separate category. And for a forfeit 5% of the time, that's when two of the guys from the bowling team couldn't make it because they were, coronavirus. All right, so, and, if someone watches this 10 years from now, they won't get it. But anyway, so what's the probability that some random competitions, go back over their various competitions and pick one at random, that it was a win? Joshua?
58%.
There's a 58% chance that whatever random competition you decide to pull from the records, for instance, they keep logs of all their different, the probability that they got a win is 58% probability. What about the probability of a loss or a tie, Lana?
37%.
37%. What about the probability that they either had to forfeit, or just outright lost? Scott?
25.
What about the probability that they did not win the game you happen to pull from that file?
42%.
42%. Questions on this? All right, any questions on or when the two things are totally separate? All right. Let me give you your homework. Let you get a head start on it then. Your homework is to do page 386, numbers 1 through 10. Got a few extra minutes here at the end of the hour to finish up that homework assignment. Page 386, numbers 1 through 10. We'll go over that on, well, not Monday, on Tuesday in our next lesson. And then we'll go into, well, what if they're not mutually exclusive events? And we'll look at those more in our next lesson. Have a wonderful rest of your day.